Nero, have you had any feedback from the job interview you attended the other day?
No, I haven't, but I'm hoping to get a positive feedback.
I hope and pray you get the job.
Yeah, thanks bro. I think I have a text message. Let me check. Yes, I have been offered the role of a civil engineer at Ruccanero Construction Limited. Wow, what a good news. I can't wait to resume my new role.
Welcome Nero, nice to meet you.
Thank you, manager. It's my pleasure meeting you too.
I believe you are ready to hit the ground running on your new role.
Yes, I am ready to start right away.
Alright then, I will see you later at your work desk. I think I have a task for you.
That's fine, let me settle in and I will be expecting you.
Hey Nero, how are you settling in?
Very fine, thank you.
Alright, I have a quick task for you in your first official assignment. Our team is constructing a bridge somewhere in town and we need to design the metal framework. For now, we just want to understand how much gap to leave between the metal work. I will send you the details in an email and hopefully, you can work with it.
No worries, I will be expecting your email. Oh, the email from my boss just dropped. Let me see what it is. I'm a bit confused on what to do about this project. I need to call Steve and know what he thinks, since we studied the same course. Who knows, he might have an idea on the project. Hey Steve, I just got my first assignment from my manager but I'm kind of confused on what to do. I think I'm nervous.
Calm down Nero. Can you tell me what it is? Maybe I can help. You know we both studied civil engineering.
I have been asked to design the gap required for the steel metal work for a bridge construction.
Oh, that. You don't need to be nervous. Do you remember the calculation on linear expansivity from basic physics?
Yes, I do.
Great. Just put down some of the parameters, recall the basic equation and play around with it. I believe you will be fine.
That's true, you're right. Thanks for the support and insight. I'll get right into it and I'll let you know the outcome later. Thanks Steve.
So, let us look at how Nero designed for the safety gap in the bridge construction. Before then, let's take a look at the scenario again. Steel bars, each of length 25 meters, are to be used as girders for the construction of the bridge at fletting phase 2. The bars are at room temperature of 21 degrees Celsius. It was estimated that the maximum expected temperature in the region during summer is 41 degrees Celsius. Could you please design for the safety gap that must be left between successive steel bars? The linear expansivity of the steel bar is given as 1.3 times 10 raised to the power minus 5 per K. Before we look at Nero's solution, let us understand what Nero is about to do. If you've observed carefully while driving across bridges or driving along bridges, you start hearing some clicky sound at regular intervals along the bridge. Sounds like click, click, click at regular intervals. Those points where you have those clicking sounds are points where gaps were allowed for in the construction of the bridge for expansion of the steel metals or the metals used for the bridge construction. Without those gaps, the bridge is going to collapse. So in this scenario, Nero was tasked with the responsibility to design for that safety gap that will be required between the steel bars used for the bridge construction. So Nero quickly recalled all the parameters from the scenario. The initial length of the rods are 25 meters. The initial temperature, which is the room temperature, was 21 degrees Celsius. The final estimated temperature that can be attained at summer in that region was 41 degrees Celsius. The linear expansivity of steel was given as 1.3 times 10 raised to the power minus 5 per K. And Nero is calculating for the increase in length to determine the gap to allow for. Nero quickly recalls the formula for linear expansivity, which is increase in length all of our original length times temperature change. Nero needed to calculate for the increase in length, so he makes delta L subject of the formula, and when he makes delta L subject of the formula, he multiplies linear expansivity by the original length by temperature change. Again, the temperature change is the difference between the final temperature and the initial temperature, so he rewrote the formula this way. And then from here, Nero substitutes his values into the formula, so that the increase in length becomes 1.3 times 10 raised to the power minus 5 to represent the linear expansivity, 25 for the length of the steel rod, and 41 minus 21 representing the difference in the temperature. And then Nero continues the calculation, and that reduces to 1.3 times 10 raised to the power minus 5 times 25 times 20. And when he puts this value into the calculator, Nero achieved an increase in length of 0.0065 meters or 6.5 millimeter. Therefore, Nero recommended to his manager that the minimum of 6.5 millimeter gap is required between the steel bars. After this calculation, Nero submitted the report to the manager. Let's look at the conversation further.
I called you in because I have reviewed your report on the project I gave to you. I must say that I am very impressed. Your design was great and I've advised the on-site team on what to do accordingly. I knew you were the right man for the job.
Thanks, boss. I am happy I was able to make a useful contribution to the team on my first day at work. And I hope to deliver more projects in the future.
Tell me, how did your first task go at work today? What was the outcome?
It was great. I applied the principle of linear expansivity as you advised and my manager loved it. Thank you once again for the support. You're a lifesaver.
Don't mention bro. What are friends for? I get your back anytime.
Lus.
School.
No be scam.